Howdy folks, I'm going to share you something in a moment. I have to install my camera for a moment. Yep, here I am. Okay, I'd like to share with you something, a theory, an idea that I just picked up this afternoon, and I'd like to share it with you. And it's about what is electricity? Where does electricity come from? What is it basically? Why do negative charges repel each other, positive charges repel each other, and positive and negative attract each other? It is also related with electromagnetic or magnetic things. And based on what I saw in the magnetic area, but also in flow patterns, I came up with the next model that I'm going to present it right now. I'm going to change the camera a little bit other way. Okay, yeah. Maybe it's a better picture, total picture. I like to present to you the flow model. What you see, and I'll give some links here down below to some films that I saw, but also made about flow patterns. If you distribute some particles like coffee grains after you finish making coffee, and then you see, and you flush it away through the sink into the gutters. Okay, well, you know what I mean. And then you see some flow patterns, which make me think, hey, something is flowing. And you see the same patterns with magnetism. If you take a magnet and you put iron powder on it, you see the same type of flow pattern. That made me think, well, hey, what has this got to do with each other? And can I use that model of something flowing also for positive and negative charges? And based on that, again, also it fires back to magnetism again. And yes, this afternoon I came up with the next model that I want to present it to you right here and right now. Okay. I hope it's very well clear. I will zoom in and zoom out. Okay. You can imagine, picture this. That a positive charge, but also a negative charge, emits some most probably particles, and I drew it like this. It is a positive particle, and I will show it from close by, and I'll zoom out so that there must be a point where you can see it clearly. I hope. Now, this positive charge is emitting all kinds of particles with a wave function of, I call it the beads and cube model. But that's just for convenience. So because I had to draw it on the paper, so I draw beads and I draw cubes or squares, circles and squares. Circle and square model, beads and cubes model, whatever you name it. It doesn't matter for now. You can always rename it later. But there is a wave function for the beads. Remember that. Okay. So every bead here. Every emitted bead has a certain kind of wave function for the positive charge in the middle, and it radiates out. It radiates out just as you have a hose for the fire brigade, as like water. Okay, remember that? The same goes for the negative charge, but then I have to draw the arrows. So these particles, in this case the cube particles or the square particles, are emitted from a negative charge with, again, a wave function for the cube or square particles. Yeah? Okay. I'll build this story up. And also this one is emitting these particles just like water. Just like spraying out water in a very strong way. Now, if you look at it from the positive side, then the positive, and I will show it to you very clearly here, and zoom out slowly so you can see it most probably. Now, The positive particle is the positive charge is emitting these particles, and they are absorbed by the negative particle. They can be absorbed by the negative charge only, and vice versa. So the beads here, the positive charge emits beads, and the beads are only absorbed by the negative charge. Okay, the same story for at the same time, parallel to this also happens, that the negative charge is sending out, emitting the cubes. I will zoom out again. And the negative charge of the positive charge can absorb only the cubes. And in this way. Now, that happened at the same time. So they are streaming up against each other like this. I hope you can see it. So the positive charge is emitting the pink beads, and the blue negative charge is emitting the purple squares or cubes. At the same time, parallel. And the negative charge can absorb only the pink beads, and the positive charge can only absorb the purple cubes. Okay? And it happens all at the same time in parallel. And the negative charge can only absorb the pink beads, and the positive charge can only absorb the purple cubes. And a positive particle cannot absorb the pink beads, and as the negative particle or the negative charge cannot absorb the purple cubes. They cannot. It's like same as with water. If two persons have a very a hose which emits a lot of water, and they stand up across each other, and two persons, they are actually flushing that water to each other, then they will repel each other because of that. The water is repelling and bouncing into each other, and gives it bounces off, etc. So they bounce off each other. But on the other side, for the positive charge, the negative charge acts like a drain. So the pink particles are absorbed like by the negative charge as a drain. So the water is like water is drained into the ground or in a pit. And the same goes for the positive charge acting as a drain for the purple cubes, or purple squares. Another thing is happening, and so that's why they can absorb each other's particles. But another thing is happening, and that is, for example, I zoomed in on the negative charge. This is the blue circumference, but the wave function of the pink particles emitted from the pink positive charge, pink positive, okay, and the wave function is altered inside of the negative charge, and by an operator, and it's changed to a wave function of the cube, and then re-emitted as a cube. So so wave functions, we know that wave functions, they can change. If I look, for example, and I also wrote that here down. Oh, by the way, I'll zoom in this in and out, so you can see it very clearly what I mean. I hope you can see it. Yeah. Okay. And where do we see this as well? A neutrino oscillation. Neutrinos can oscillate between the versions. There are more than one version of neutrinos. I think three or so electron neutrino, the muon neutrino, and tau neutrino, if I'm well, something like that. Not only that, but we also see it in what people in general call the wave function collapse. Well, I don't believe that it collapses, but it alters. A wave function never collapses, a wave function alters from one wave function to another wave function. Okay, that's what we see in the two slit experiment, like this. I'll zoom out again. A light particle or whatever kind of particle is emitted by an emitter or a source, a light source, for example, or electron source, and has a wave function of the light particle, like this. Then it passes, then goes through two slits, and we end up with the two slit pattern that we see. But at the moment that a light particle or electron particle bounces into the detection screen, then it lights up. But in that moment, the wave function alters from a single particle wave function into a bound particle wave function, because it's bound by the screen, it's absorbed by the screen, and in this state it has a single particle wave function, which is smaller and has less impact than when it meets with the wave function of the big screen. A big screen is a massive, if you compare it, it's like a football or a football hitting the moon. I mean, the moon is not changed by it, but the wave particle is changed because of the massiveness of the observation screen. This is very much bigger, so it is forced to change its wave function because it becomes confined from an unconfined free wave particle. It becomes a confined particle, so it needs to change its wave function. That's why also in the positive charge or negative charge, the wave function of the pink positive pink particle, pink bead, is altered inside of the negative charge into a purple cube wave function. Just similar that it's here altered from a single particle wave function to a bound particle wave function. And now, in this model, it's explained why they attract, because one source here, one source acts like emitting a lot of water, and the other source is acting like a drain, a strong drain. So one is emitting stuff, and the other part is absorbing it a lot and altering it. But if you have two of the same sources, like this, I'll show it to you, then these particles cannot, they both are emitting. So, and of course the same story, but then all in blue and purple goes for the negative charge, but they cannot absorb. So a positive charge can only absorb the purple cubes, and the positive, the negative, the positive charge can only absorb the purple cubes, and the negative charge can only absorb the pink beads, so to say. But a positive charge cannot, because it's emitting it, it cannot absorb the pink beads. Just like if you in the analogy with the firemen, if I'm having a hose with emitting a lot of water, another fireman cannot put with his hose put water in my hose, because my hose is emitting a lot of water. The same thing happens with likewise particles that emit, in this case, the pink particles. So you actually like two firemen emanating water from both sides, and that will never work. So that's why they repel each other. And the same, of course, but the same type of drawing, but then in blue and purple, it goes for the negative charges. And so this is what I think that is happening on very low scale with positive and negative charges. And a positive and negative charge, they can attract each other because they can accept each other's particle wave functions and alter them. And the pink positive particle can accept the purple particles, cubes, and vice versa. So they can attract each other. Because one acts like an emitter and the other one acts like a drainage system, and vice versa, of course. For these particles, he acts like an emitter and he like a receiver. So you can also say it's a sender-receiver model from both sides, and these things happen at the same time. I mean, from that to that, and from that to that. So this is actually the model what I wanted to present. How electricity functions. And of course, if you do this with a movement, then the whole thing becomes magnetic. That's why even magnetic stuff is so related to electricity, because then it becomes a moving version of this. So this is the static version of it, and magnetism is a moving version of this model. It's a flow model. Something must flow. If you watch the picture of maybe here, or I don't know, I will send some links in this movie where you can see how a magnetic field looks like. And also I made some movies about flowing particles in water, and they are similar. So also in magnetic stuff, but also in electric fields, something must be flowing. And what is flowing, we still have to find out, but I think this flow model of electricity and magnetism is maybe a viable, maybe a good model to explain what it actually is. I mean, we can see it, we can calculate it, but we don't know the deep down inside what it really is. And I hope this model explains it and will be, that this is correct, what I'm showing here. I hope it's correct, and if not, well, then I at least gave it a try. Okay, this is what I wanted to share with you. Thanks for watching. See you next time. Hasta la vista.